Hi folks, as I warned you, I'm not going to be in today again. We are going to cover 11-3 today, probability of multiple events. You should have the handout from the sub to follow through. The first thing we're going to talk about is dependent events and independent events. Dependent events are when one event affects how the other can occur. So if I have a deck of cards and I pull a card from that deck of cards and do not replace it, then choose the second card, that's dependent. That means that the second card is going to depend on what I picked out and didn't replace by the first card. Independent events are a little bit easier. That's when one event does not affect how the other can occur. So if I roll a die and then spin a spinner, what I roll on the die doesn't affect what I'm going to get on the spinner. And we want to be able to determine whether things are independent or dependent. So my first example says, determine whether the following are independent or dependent. And A says, flip a coin, then roll a number cube. So think about it for a second. If I flip a coin and then roll a number cube, does it matter what I got when I flip the coin and then roll the number cube? No, so those are independent. Independent. Make my pen a little thicker. B says choose a marble from a bag, keep the marble, and then choose another marble from the same bag. That means that the marble that I took out and did not replace is going to affect what's left in the bag. So that's what we call a dependent event. Now, if we want to look at events and determine the probability, we're going to need to know whether it's independent or dependent. Misspelled independent up there. There you go. So the probability of A and B. If A and B are independent events, that means they don't affect each other, then P of A and B is simply P of A times P of B. So if I want the probability of rolling a 6 on a fair number cube and then flipping a coin and getting tails, I would just do P of 6 times P of tails. Now, P of 6, how many ways can we get a 6 on a fair number die, or number cube? One way, so that's going to be 1 out of 6. How many ways can we get tails if I flip a coin? Well, there's heads or tails, so 1 out of 2. And if I multiply that together, I get 1/12. So what is the probability of spinning a spinner numbers 1 through 5 and getting an odd number, and flipping a coin and getting heads? Again, spinning the spinner and flipping the coin have nothing to do with each other. So I'm going to do P of odd times P of heads. Now, how many ways can I get an odd number on a spinner numbered 1 through 5? Let's see, 1, 2, 3, 4, 5. Odd numbers are 1, 3, and 5, so 3 out of 5. And flipping a coin and getting heads, there's heads or tails, so 1 out of 2. And multiply straight across, and we'll get 3/10. Probability of odd and heads is 3/10. So, what is the probability of choosing a black card from a standard deck of 52 cards and rolling an even number on a fair number cube? Well, we'll have probability of black. And again, this is independent because choosing a card from the deck and rolling a number cube aren't going to affect each other. So probability of black times probability of even. See, deck of cards, black cards. Well, a deck of cards has 52 cards. Half are black, half are red. So half would be 26 out of 52. Or, really, I could just say 1/2. Why don't we try doing that? Let's see if I can go back. Well, I guess I can't go back. We're going to leave it as 26 out of 52. Probability of getting an even number on a fair number cube. Let's see, 1, 2, 3, 4, 5, 6, 2, 4, and 6, so 3 out of 6. And as I just said, that's really 1/2 times 1/2. So 1/4 is the probability of getting a black card and an even number cube. Okay, continuing to the back. Mutually exclusive events are two events that can't happen at the same time. So rolling a 2 and a 3 on a fair number cube, can we get a 2 and a 3 if we roll one die? No. So that's called mutually exclusive. Mutually exclusive. Or you can abbreviate that ME. Just remember what ME stands for. It's not just me. How about rolling an even number and a multiple of 3? An even number and a multiple of 3. Let me see. If I roll even numbers, that could be 2, 4, 6. And 6 is a multiple of 3, so that's something that can happen at the same time. So we would say that is not mutually exclusive. Choosing a red card and an even numbered card from a standard deck of 52 cards. So remember, mutually exclusive means they can't happen at the same time. So can I choose a red card and an even numbered card? No. That is not mutually exclusive. It's real easy to pick a 2 of hearts or a 4 of diamonds. Okay, choosing a red card and a black card from a standard deck of 52 cards. Are there any cards that are both red and black? No, so that is mutually exclusive. Can't do both of those at the same time. Now, we're still going to find probability. We're going to find probability of A or B. So we have P of A or B as P of A plus P of B minus P of A and B. So we take the probability of event A happening, add the probability of event B, and then subtract the probability of both of them happening at the same time. However, if they are mutually exclusive, then we can just add them together and not worry about subtracting the P of A and B because there won't be any P of A and B. Basic problem, students are allowed to choose one elective each school year, only one elective. About 18% chose woodworking and about 38% chose music. What is the probability that a student chosen at random has selected woodworking or music as an elective? Well, these are mutually exclusive because they can only choose one elective. So they can choose woodworking or music. They can't choose both. So if it's mutually exclusive, we just add them together. So 18% plus 38% equals 56%. So the probability the student chose woodworking or music is 56%. The numbers 1 through 10 are written on index cards and placed in a box. What is the probability that a card chosen at random has a number that is greater than 7 or even? Greater than 7 or even. So greater than 7 would be 8, 9, or 10, so 3 out of 10. Plus even would be 2, 4, 6, 8, or 10, so 5 out of 10. But then we have to subtract numbers that are both greater than 7 and even. So we said greater than 7 was 8, 9, and 10, but 8 and 10 are even, so we have to subtract 2 out of 10. So we'll end up with 3 plus 5 is 8, 8 minus 2 is 6 out of 10, or we could say 60% probability. Now, another way of looking at this is thinking, okay, if I want greater than 7 or even, then I could have 2, 4, 6, 8, or 10, or I could have 8, 9, or 10. So I'm really counting 10 and 8 twice. So if we do it again, 2, 4, 6, 8, and 10, and then add the 9, we would get the 6 out of 10. And that ends our examples. You have a worksheet to continue working on. As I told you, I will not be back tomorrow, and you will work on a review tomorrow for the quiz on Friday. I will put answer keys to everything in Schoology, so if you're having some questions, the worked out answer keys are in Schoology, so that you can look and see what I did to figure out what you need to do. I will be we will have time to review before the quiz on Friday, so you can plan on having a chance to ask questions before we have the quiz. Good luck, guys.